Hello everybody, welcome back to CalcFly videos. In this video we're going to be talking about AP Calculus AB 2017 free response questions. In this video specifically we're going to be focusing on question 3. So as you know that question 3 is it's not calculated permitted problem, and also along with that information we have some given information. For example, the graph of first derivative and also the value of f of x function at x equals -2. Alright, so we're going to be using this two information to be able to find the solutions to the following problems. So, let's get started. In the first problem, part A, it says what is f of -6? So, since we're given the first derivative and this value, we're going to be using these two values, okay? These two given information. So, in order to find the f of -6, I can set up this formula. So, f of -2 plus using the definite integral from -2 to -6 f of x, actually f prime x dx. Okay, so from here, since the upper bound is less than the lower bound, so I need to switch them. So when I switch them, we're going to get this f of -6 is going to be equal to f of -2 minus integral from -6 to -2 f prime x dx. So in this case, we know the value of f of -2, which is given right here, so 7, minus, in order to calculate this definite integral, that means actually finding the area under the curve. So finding the area under the curve. Okay, so from -6, let me use a different color. So from -6, which is right here, to -2. Which is right here. So basically it looks like a right triangle. So since also this right triangle is above the x-axis, which means the area value will be positive. So the area of this right triangle will be, the height is 2 and the base is 4, so it's going to be 2 times 4 divided by 2. So these 2's are going to be gone. So 7 minus 4, we got 3 for the value of f of -6. So we're going to be doing the same thing for finding f of +5, but before that I need to clean up the board. So for that we're going to be doing the same thing using the definite integral. So f of +5 can be found again doing the same thing, f of -2 plus definite integral from -2 to 5 f prime x dx. So we already know f of -2, which is 7, plus, so this definite integral will be again the area under the curve from -2 to 5, but as you notice that from -2 to +2, it's below the x-axis, which is a semicircle, so we're going to be finding the area of this semicircle. So it's going to be equal to, let me open up a parentheses, the radius is 2, as you know that, as you can see that, the radius is 2, so it's going to be pi times 2 squared divided by 2, and it's going to be negative because it's below the x-axis, and plus, so from +2 to 5, it's going to be the area of this triangle. So the base is 3, the height is 2, so the height is 2, so it's going to be 3 times 2 divided by 2. So these 2's are going to be gone. So finally my answer, 7 minus 2 pi plus 3. So if I combine the like terms, we're going to get from here f of 5 is going to be equal to 10 minus 2 pi. That's the final answer. Okay, so that's part A. So let's move on to part B. Again, let me clean up the board. In part B, we're being asked to figure out on what intervals f of x is increasing. So we know that if f of x is increasing on a specific interval, that means f prime x is positive on those specific intervals. So basically, we're going to be look at where the f prime x values are positive. So since we are given the graph of first derivative, any point on this graph can be represented by x comma f prime x. So which means we're going to be switching the y values with f prime x values. So the f prime x values are positive right here until negative 2. So between negative 6 and negative 2, f prime x values are positive. So that's the first interval. So negative 6 comma negative 2. And also from positive 2 to positive 5, again the f prime x values are positive. So that's another interval, positive 2 and positive 5. So basically on these two intervals, f of x is increasing. Okay. Alright, let's move on to part C. In part C, we're being asked to figure out the absolute minimum value. So we know that absolute minimum value can occur at either critical points, or endpoints. So we know my endpoints. So negative 6 until 5, okay? And in order to figure out the critical point, we need to know what is the local minimum. So we know that we can find out the local minimum by looking at the graph. When the local minimum happens, the f prime x should change from negative to positive. So look at that. This is positive to negative. But right here, it's changing at x equals positive 2. It's changing from negative to positive. Okay, so basically, this 2 is my local minimum. So basically, my absolute minimum value should occur at x equals negative 6, 5, and x equals 2. So now we're going to analyze these values. Okay, so let's do it. Before that, I need to clean up the board. So basically, we're going to kind of make a table to analyze these values. Okay, so it's going to be like this. This is x, this is f of x. Okay, so I'm going to put the values negative 6, 2, and 5. Okay, so in this case, as you know that we got the f of negative 6 value as 3, remember that. And also 2, f of 2 value is going to be equal to, again, can be found by, I'm going to do it over here, f of negative 2 plus definite integral from negative 2 to positive 2 f prime x dx. So if you make great use of this formula, so you're going to end up with this value for the f of positive 2, that's going to be equal to 7 minus 2 pi. And we already know the value of f of 5 from the part A, so that's going to be equal to 10 minus 2 pi. So since we know all these three values, so we need to figure out which one came out to be less than the others. So 7 minus 2 pi came out to be less than the others, so that's why my absolute minimum value is going to take place at x equals 2, and this is the absolute minimum value, 7 minus 2 pi. Okay, let's move on to part D. In part D, we're being asked to figure out f double prime negative 5 and f double prime 3. So since we're given the graph of first derivative, so we can easily figure out approximately the value of f double prime negative 5 and f double prime 3. So basically, their values are going to be the slope value locally at around negative 5 and at around x equals 3. So part D, and use a different color. So f of f double prime negative 5. So negative 5 is right here. So basically, the slope of f double prime negative 5 is going to be equal to the slope of this line, approximately. So it's going to be equal to 2 minus 0 divided by negative 6 minus negative 2. That's going to be equal to 2 divided by negative 4. That's going to be equal to negative 1/2, because the line is falling down, which means the slope will be negative. Okay, we got the f double prime negative 5. But when it comes to finding the the second derivative of f of x function, so f double prime 3, it's not going to be that easy. Why? Because look at that, the slope of this line, so let me quickly clean up that part so you can see it clearly. So when you look at this part, so after 2, the slope of this line is going to be positive, because the line is rising up, which means the slope is positive. But right after x equals 3, the line is falling down, so which means slope is negative. So you can think about this like the left hand side slope and the right hand side slope, and they're not equal to each other. Since they're not equal to each other, that means the slope, the derivative does not exist. So basically, f double prime 3 does not exist. Okay? Alright guys, in this video we talked about question 3 from 2017 AP Calculus, AB, free response portion, and we tried to find solutions to the following problems, as you can see. Thanks so much for watching. Don't forget to subscribe, like, share, and comment. See you in the next video. Bye bye.